somewhere beneath the swirling orange clouds of the largest planet in our solar system. There could be an ocean of liquid metal, storms larger than entire planets that have raged for centuries without stopping, and pressures so extreme they can crush hydrogen into a state of matter that barely exists anywhere else in the known universe. For over 400 years, humans have stared at Jupiter through telescopes, watching its colorful bands drift and its great red spot churn endlessly. But what lies beneath those clouds has remained one of the greatest mysteries in modern astronomy. Even today, with spacecraft orbiting closer than ever before, scientists are finding data that contradicts everything they thought they understood about this giant world. What is really happening inside Jupiter? Why does its interior refuse to match our models? Today, we descend beneath the clouds of the solar system's largest planet to uncover 10 mysteries that scientists still cannot fully explain. Jupiter is often introduced with numbers so large they barely feel real. It is more than 11 times wider than Earth, so massive that every other planet in the solar system could fit inside it, with room to spare. Its gravity is so powerful that it acts like a cosmic shield, pulling in or flinging away comets and asteroids that might otherwise threaten Earth. Its mass is more than twice that of every other planet in the solar system combined. And yet, despite being studied for centuries, Jupiter remains one of the least understood worlds we know. Unlike Earth, Jupiter has no solid surface to land on, no clear boundary where atmosphere ends and ground begins. Instead, its gases grow thicker and thicker with depth, compressed by unimaginable pressure until they behave in ways barely predicted by physics. Sending a spacecraft to study what lies beneath those clouds is not simply difficult. It borders on impossible, which is exactly why every mission that has attempted it has returned data that challenge scientists rather than confirming what they expected. To understand why Jupiter poses such a profound challenge, you have to consider the sheer scale of the unknown involved. Earth's interior, though still mysterious in places, is at least built from familiar materials, rock, metal, and molten layers that scientists can model using known physics. Jupiter is different. It is composed almost entirely of hydrogen and helium, the same elements that make up stars, and deep inside its atmosphere, the pressure becomes so extreme that hydrogen gas is forced into a strange, exotic state called metallic hydrogen, a substance that conducts electricity like metal despite starting as a gas. No laboratory on Earth can naturally recreate these conditions for extended study, meaning scientists are forced to rely on brief spacecraft flybys, distant observations, and complex simulations to guess what is actually happening thousands of kilometers beneath the surface. The first mystery involves the Great Red Spot itself, a storm larger than Earth that has been observed for at least 150 years and possibly much longer. No one fully understands why this storm has persisted for so long, when storms on Earth typically dissipate within days or weeks. Even stranger, recent observations show the Great Red Spot has been shrinking for decades, raising the unsettling question of whether one of the solar system's most iconic features might eventually disappear entirely. And if it does, what could possibly replace it? The second mystery involves Jupiter's internal heat. Despite being far from the Sun, Jupiter radiates almost twice as much heat into space as it receives from sunlight, meaning something inside the planet is generating enormous energy on its own. Scientists believe this may be linked to the slow gravitational compression of the planet, or possibly helium rain falling deep within its atmosphere, releasing heat as it sinks. But the exact mechanism remains only partially understood, leaving a fundamental question about the planet's internal engine still unresolved. The third mystery is the discovery, made by the Juno spacecraft, that Jupiter's magnetic field is far stranger and more irregular than expected. Instead of forming a smooth, symmetrical pattern like Earth's magnetic field, Jupiter's field contains unexpected bumps and asymmetries, particularly around its northern hemisphere. This suggests the processes generating the magnetic field deep inside the planet are more complex and chaotic than any previous model predicted, hinting at a turbulent, poorly understood interior. The fourth mystery involves the depth and structure of Jupiter's colorful cloud bands. Scientists once assumed these bands were relatively shallow atmospheric features, but data from Juno revealed that the jet streams driving these bands extend thousands of kilometers beneath the visible clouds, far deeper than anyone expected. This means the storms and patterns we see from Earth are only the surface expression of massive, deep atmospheric currents that scientists still cannot fully model or predict. The fifth mystery concerns Jupiter's core. For decades, scientists assumed the planet had a small, dense, clearly defined core at its center. But gravitational measurements from Juno suggest the core may actually be diffuse and partially dissolved, blending gradually into the surrounding layers rather than existing as a distinct solid structure. Some researchers believe this unusual core may have resulted from a massive collision early in Jupiter's history, an event that could have reshaped the planet's interior in ways still being debated today. The sixth mystery involves powerful lightning storms detected deep within Jupiter's atmosphere, some occurring in regions previously thought too cold and too deep to support the kind of electrical activity needed to generate lightning. These storms behave differently from lightning on Earth, flashing at different frequencies and originating from cloud layers scientists did not expect to be electrically active, raising new questions about the composition and behavior of Jupiter's deep atmosphere. The seventh mystery is the unexpected turbulence found at Jupiter's poles, where Juno discovered massive, tightly packed cyclones arranged in geometric patterns unlike anything seen on any other planet. At the North Pole, 8 cyclones swirl around one central storm, while the South Pole contains a slightly different arrangement of 5. These storms have remained remarkably stable for years, and no one fully understands why they formed in such a precise, symmetrical pattern, or why they have not merged, dispersed, or collapsed like similar systems eventually do on other worlds. The eighth mystery involves auroras, far more powerful and complex than anything observed on Earth, generated near Jupiter's poles by interactions between the planet's intense magnetic field and charged particles from its moons, especially volcanic material ejected from Io. These auroras release energy hundreds of times greater than Earth's most powerful auroral events. Yet significant aspects of how they form and behave remain only partially explained, especially unexpected high-energy particle bursts detected during close spacecraft flybys. The ninth mystery concerns the strange chemical composition detected in Jupiter's atmosphere by the Galileo probe, which descended directly into the clouds in 1995. Instead of confirming expected levels of water and other compounds, the probe found far less water than predicted, along with unusual concentrations of certain gases, results so surprising that scientists still debate whether the probe simply entered an unusually dry region, or whether our understanding of Jupiter's atmospheric chemistry is fundamentally incomplete. The 10th and perhaps most profound mystery is the question of whether Jupiter's deep interior contains conditions that could theoretically support exotic forms of chemistry entirely unknown to science, under the extreme pressure and temperature found deep within the planet. Some researchers speculate that entirely new molecular structures could form, structures that simply cannot exist naturally anywhere on Earth. If true, Jupiter's interior might represent one of the most alien chemical environments accessible anywhere in our solar system, hidden forever beneath thousands of kilometers of crushing atmosphere. These mysteries matter far beyond simple curiosity about a distant gas giant. Jupiter played a defining role in shaping the early solar system, its immense gravity influencing the formation and arrangement of every other planet, including Earth. Understanding how Jupiter formed and what lies beneath its clouds helps scientists reconstruct the earliest chapters of our solar system's history, offering clues about why our particular arrangement of planets exists at all. Jupiter also serves as a crucial comparison point for the thousands of gas giant exoplanets discovered orbiting distant stars, many of which appear even stranger than Jupiter itself. Every mystery solved here helps astronomers interpret worlds we may never visit directly. Using Jupiter as a nearby laboratory, for understanding gas giants across the entire galaxy. The impact of these discoveries has also reshaped space exploration priorities. NASA's Juno mission, launched specifically to peer beneath Jupiter's clouds, has already forced multiple revisions to textbook explanations of gas giant interiors, and its findings continue to influence how future missions are designed. Scientists are now planning additional missions specifically aimed at studying Jupiter's moons, particularly Europa, partly because understanding Jupiter's full system, not just the planet itself, is considered essential to understanding how planetary systems function throughout the universe. Every answer Jupiter provides tends to generate several new questions, turning this single planet into one of the most actively studied and endlessly surprising objects in modern astronomy. Not everyone views these unresolved mysteries the same way. Some scientists see them as frustrating gaps in an otherwise well-understood field, evidence that our models of planetary formation and behavior remain incomplete despite decades of research. Others find genuine excitement in the uncertainty, arguing that a fully understood Jupiter would actually be less interesting, offering no new questions to drive future exploration.